So today we're going to cover Chapter 9, Section 3, and we're going to be using similar right triangles. So the first slide is a theorem. Again, do not memorize the number. Understand what it says and what it's telling you to do. So if the altitude is drawn to the hypotenuse of a right triangle, then two triangles formed are going to be similar to the original triangle and to each other. Now, what's important here is that the original triangle, and in this picture it was ABC, is a right triangle. Now, the little right angle wasn't there, or if it was hard to see. So that is, the original yellow one is the original right triangle. Now, this side over here, the BC, this is the hypotenuse. And what's happening is they're going to draw in an altitude. And then it's going to split that big yellow triangle into two smaller right triangles, which are going to be similar to the yellow one, which are going to be also similar to each other. So it's creating a little one here on the left, which I'm outlining in red, and then another, like a medium-sized one, here on the right. So I now have a yellow, a red, and a blue triangle in this picture, and they're all similar. You're going to be asked to write similarity statements, just like you did in Chapter 8. Now, notice there's no numbers here or no congruency marks on the angles. So what I would do is find how you're going to come up with this similarity statement. Whether you go from hypotenuse to longer leg of each triangle, hypotenuse to shorter leg, or maybe shorter leg to longer leg to hypotenuse, however you want to trace around the sides of the triangle. I'm going to start out with the yellow triangle first. And I'm going to start out by going from, I'm going to go from the hypotenuse to the shorter leg. So what I'm doing is I'm going from the hypotenuse of my original yellow. So I'm going to go from the B to the C over here to the shorter leg, which is going to meet up at the right angle. So I'm going to start out with B. And again, you can start out in any order, but then the next two triangles have to match it. So this is the large yellow one. Now I'm going to go to the medium-sized one, the blue one. So from here, I'm going to go, and here's the right angle on the blue one. It's right here, this yellow right here. So my hypotenuse of the blue one is going to be the BA. So I'm going to go on this one, I'm going from here up the hypotenuse of that blue triangle and then down to its right angle. So I'm going to say BAD. And then for the red one, again, I'm going to go up the hypotenuse, which is the AC, and then over the shorter leg to the right angle. So from A to C to D. And this would be your similarity statement. This was for the blue. So be able to match everything in this picture. Everybody good? All right, we're going to do an example of this, and on the next slide, I'm actually going to pull them apart and sit them in the same orientation, so maybe it'll be a little bit easier to see. Yeah, and then maybe it'll be a little bit easier to see. So it wants me to identify the similar triangles in the diagram, so it wants me to write a similarity statement. So I'm going to go ahead and outline the original B in blue. The original's right angle is right here. So SR or RS is my hypotenuse here. So I'm going to try to draw them all in the same orientation. So this is the original. And now I can draw this, I'll draw the medium-sized one. I'll do that one in red. And notice the right angle on this one is now at the U. So if I go to flip this and sit it the same way, this is going to be U here, and then the T at the top and then the R over here. And then I'll do the other one on the other side, this little one. So again, sit it in the same orientation. The U is down here, the S would be here, and then the T is right here. So if you can pull them apart, then writing the similarity statement isn't as bad. So then what we'll do here is I'm going to go up the hypotenuse. So up and then down on all of them. Up and on down, up and down on all of them. So my first triangle, the purple one, I'm going to write it as TSU. And then for the red one, RTU. And then for the blue one, RST. So if you want to try to pull them apart, it might be writing that similarity statement a little bit easier. Pretty good there? So, so this is similar to what we did in chapter 8, except for we've got to pull them apart and then match the sides. And again, they're all going to have a hypotenuse because they're all going to be similar right triangles. The next slide, we're going to identify what it means to have a geometric mean. Now, when you're doing any of the problems in the homework tonight, remember, I'm going to be teaching you two proportions from a theorem that you can use. But again, remember, you can use your knowledge from chapter 8. You can set up similarity proportions. Remember those statements of proportionality that you wrote on the chapter 8 quiz and test? You can use these proportional sides from these three triangles also to find missing pieces of these triangles. So just always remember that you can use the fact that these are similar figures and their sides are proportional. So let's go ahead and see what a geometric mean is. So a geometric mean is basically when I give you two numbers, I'm going to ask you to multiply them and then square root that product. So we're going to be using the geometric mean and the two proportions coming up on the next couple slides. Now, when you're doing this in the homework, if it says to find the geometric mean of two numbers, you don't need to put it in the proportion. You can just multiply them and square root the product. So, but the bottom line here is you're doing cross products, x times x, and then a times b. So you would end up getting x squared when you do x times x, and then a times b is ab. And then if you want to find x, you got to square root it. So x is equal to the square root of a times b, or the product of a and b. So let's try to find a geometric mean given two numbers. Now, you don't have to put it in the proportion as long as you understand that geometric mean means you take the two numbers, multiply them, and then square root that product. You don't need to write geometric mean in a proportion. Now, we have two options of solving this. Because I multiply this, I get 80. 80 is not a perfect square. On the questions on the quiz that I'm going to give you, if I ask you to find a geometric mean, I will want the answers exact or in simplest radical form. So if on the quiz you tell me that the square root of 80 is 8.9, and I say simplest radical form, you just got it wrong, because I want to see you break that 80 down. Now, you can either choose to multiply it, and then you're going to have to go back and factor it anyways, so you might be better off just leaving the 4 and the 20 separated, and then do the factor tree right from there. So this becomes 2 and 2. This becomes 4 and 5. The 2's are all coming down here. The 4 becomes a 2 and a 2 again, and then the 5. So again, all of these were under square roots still. And then you go back, look for your pairs, a 2 A 2 comes out. Poor 5 doesn't have anybody to pair with. He stays underneath. So 4 square root 5. So either way, if after you multiply them and it's not a perfect square, you still got to go back and break it down. So you're better off leaving it unmultiplied and just do a factor tree with those two numbers. Everybody with me on that? All right, now the next one. Now, because you're using a calculator, you could have quickly done 4 times 20, hit that square root button. As soon as you see it's a decimal, go back and then do the factor tree. On this next one, if you do that, 9 times 25, if you think about it, 9 quarters is $2.25. If I square root that, that's 15. So in this particular case, you can quickly do it on your calculator. Another thing you could look at is these two numbers that you were asked to find the geometric mean. They're both perfect squares. So that's a clue that that product should also be a perfect square. Now, if you weren't using a calculator, which usually we don't for the quiz, what I would have done here is if you didn't know 225 was a perfect square, you can do the factor tree. And then right away I'm at prime. I got a pair of 3s, 3 comes out, pair of 5s, 5 comes out, 3 times 5, 15. Same answer I got as if I just multiplied them. So again, these you could do either way. Again, since you're using your calculator, you could quick multiply them, hit that button, and if it's not a decimal, then that integer is your answer. But if it's a decimal, you know you got to go back and do it by hand. Pretty good there. All right, now you're going to see how we're going to use this in the proportions for the next two theorems. So the first theorem is called the geometric mean altitude theorem. And what this one states is that in a right triangle, the altitude from the right angle to the hypotenuse divides the hypotenuse into two segments. The length of the altitude is the geometric mean of the lengths of the two segments of the hypotenuse. So let me trace through and explain what all of these words mean. So here is my original right triangle. It's got the right angle up here. And then the words say that when you draw the altitude from the right angle, so coming out of the right angle, down to the hypotenuse, this side over here, this is the hypotenuse. That altitude splits the hypotenuse into two smaller pieces called segment 1 and segment 2. And again, you can see right in here, they've written the word altitude. So this would be the proportion that you're going to use when you're looking for either the altitude or segment 1 or segment 2. Then we're going to learn the other theorem, and then we're going to do an example using both of these theorems. Pretty good. All right, now, just to identify, also in this picture, remember the whole yellow thing is a right triangle. So this side here is a leg, and then this side over here is also a leg of the original triangle. So this is what we're going to need to see coming up on the next slide. And we're going to use the next proportion to find a missing leg. So let's see how that one's going to work. So the next one is called the geometric mean leg theorem. And again, same thing. In a right triangle, the altitude from the right angle to the hypotenuse divides the hypotenuse into two segments. The length of each leg of the right triangle is the geometric mean of the lengths of the hypotenuse and The segment of the hypotenuse that is adjacent to the leg. Lots of words here. I'm going to give you an acronym for this last part of this last sentence. So right here where it says segment of the hypotenuse that is adjacent to the leg, because that's the part that's going to go in the bottom of this fraction. I give it an acronym. I'm going to call that acronym, I call it SOHAL. And the S stands for the word segment. The O in the acronym stands for of. The H in the acronym stands for hypotenuse. The A in the acronym stands for adjacent. And the L in the acronym stands for the word leg. Now I'm going to go to the picture and I'm going to label the A, B, C, X, Y, and I'm also going to add in a Z there. I'm going to identify all of those variables. So again, this is my original right triangle. I'm drawing the altitude straight down to the hypotenuse. So I'm going to call this Z, and this is my altitude. The X is a leg of the original right triangle. The Y is also a leg of the original right triangle. The C is the hypotenuse of the original right triangle. So this side right here. The A is segment 1. The B is going to be my segment 2. Now you can flip-flop the segment 1, segment 2. It doesn't matter. So now that I've identified all of the pieces here, I can show you how it's going to tie in to the proportion. So again, the proportion, we're going to take the hypotenuse. We're going to do 2 of them. I'm going to do 1 for the purple leg and 1 for the pink leg. So the top of the fraction here is the hypotenuse on both. And then what I'm going to do here is notice in the thing, I'm going to put the leg. So I'm going to put a purple leg here, and then the SOHAL. What this means is it's the segment of the hypotenuse. So the piece of the hypotenuse that is adjacent, that is next to the leg. So the blue segment is next to the purple leg. The red segment is next to the pink leg. So the SOHAL for the pink is the red. It's the segment of the hypotenuse. So the piece of the hypotenuse that's right next to that leg. Everybody with me on that? Okay. And then over here, this would be pink leg, and then its segment, its SOHAL is going to be segment 2. So this is the SOHAL, the segment of the hypotenuse that is adjacent to the leg. And now we're going to use these 2 proportions to answer the next 2 examples. Remember, you can also realize you have 3 similar triangles here. Again, you can just use the proportions like you did in chapter 8 also to find missing pieces. But it's nice when you have different places that you could put your numbers. Now, what I'm going to do is I'm going to duplicate the next slide because I don't want to have to, it's going to get kind of messy when I do part A of example 3. So I'm going to duplicate the slide so I can have the same picture for both A and B. So let me go ahead and do that. On this slide, I'm not going to do B. I'm only doing A. So I'm going to go ahead and label my picture and I'm going to color code it so maybe you'll see things a little bit clearer. Okay, so for part A, they've given me JR, which again, JR, remember this is segment 2 that I call it. And then EJ, that's this segment. This is my segment 1. because remember, this is the hypotenuse. And my right angle in my triangle is up here. Now, this is a leg. This is a leg. And then my altitude is right here. Now I'm going to add variables here, just to make it easier when I put it in my proportion. So the purple leg, I'm going to call this one Z. The pink leg, I'm going to call this one Y. My altitude, I'm going to call this X. Now my hypotenuse, I'm not going to give a letter to, because I can already figure out the length of the hypotenuse by adding segment 1 plus segment 2. And the length of my hypotenuse, 9 plus 16, is 25. So that's going to be the length of RE. So that's 25. Next, I'm going to use my proportions now. Since I have the blue and the red, the two segment pieces, I'm going to use my first proportion. And the first proportion I'm using is going to be segment 1 over altitude equals altitude over segment 2. And now I'm going to put in those two numbers that I have. Again, it's the geometric mean altitude theorem. So I'm going to put 9 over x and x over 16. Now, if you would notice again that once I do these cross products, the two numbers I'm multiplying are perfect squares. So I could go ahead and multiply them since you guys are using a calculator. 9 times 16 is 144. Square root both sides, and x is 12, which is also my altitude, which they called HJ. So HJ has a length of 12. So now I have a piece up here that I can fill in. And I can put it right here. Next, I'm going to use the other proportion. So remember, the other proportion was hypotenuse over leg, leg over Sohal. I'm going to do this 2 times. One for the pink leg, one for the purple leg. I'll do purple first. So my hypotenuse, remember I added the 9 and the 16, so my hypotenuse was 25. I don't know the length of my purple leg, so that's Z. The segment of the hypotenuse adjacent to that leg is the blue segment. So its Sohal is going to be the blue, and it's the 9. Again, I'm going to do the cross products here. Z times Z is Z squared. And then I'll do 25 times 9. 25 times 9, again, these are both perfect squares. So I could just go ahead and multiply this, and I get 225, square root it, and I get 15. Now, if the two numbers you're multiplying aren't perfect squares, then what I would do here is probably factor them, and then just get it in simplest radical form. So Z is the side HE. It's that leg up there. Now I got to do the pink one. Still got the same hypotenuse. It's 25. And now I'm going to do pink. It's Y and Y. And then its Sohal is the red. It's the 16. Again, do the cross products. Y squared is equal to 25 times 16. 25 times 16. Now, in this case, let's say you weren't using a calculator. Remember, you're going to square root them. I could square root the 25 and then the 16, and then it goes right to what my answer is. If I multiplied this, this would have been the square root of 400. And Y, which is the RH, the other leg. And now I've found all the pieces of my triangle. Now I'm going to do part B, doing the exact same proportions and find the missing pieces of the triangle. Okay, let's try the last example. Again, I'm not doing part A, I already did it. It's the same picture, I just duplicated my slide. So let me fill in my given. JR is 4, and they gave me the altitude this time, it's 2. So I can go ahead and label everything again. This is Z, remember it's a leg. This is Y, and again, you can pick whatever letters you want. And then this is segment 1. I don't know it, I can call this X. And then this will be my hypotenuse. I'm not going to give it a letter because once I find the blue segment, all I have to do is add that answer to 4. So let's go ahead and set this up. So I'm going to do the first proportion that we learned. I'm using the segment 1. Let me do it in color again. So segment 1 over altitude equals altitude over segment 2. So my segment 1, I don't know. This time they gave me the altitude. It was 2. And then segment 2 was 4. This time I don't have to do a square root. I don't have a square. So I'm going to do 4 times x and 2 times 2. Divide by 4. And x equals 1. So that was the blue. That was segment 1, which was in the picture EJ. So this is now equal to 1. So my hypotenuse is 1 plus 4. So my hypotenuse is 5. And that is the RE. So this is 5. And then I just did EJ, and that was 1. So now again, I'm doing the same one, the hypotenuse over leg, leg over the Sohal. I'm going to do it 2 times, 1 for pink, 1 for purple. Hypotenuse I just found, it's 5. I'm going to go ahead and do purple first. Z, Z, and remember, its Sohal is the blue, and we just found it, it's a 1. Going to cross multiply. I end up getting Z times Z is Z squared. 5 times 1 is 5. I'm just going to square root this because I'm leaving it in simplest radical form. So Z is equal to the square root of 5. And Z was HE. So HE is the square root of 5. Now I got to do pink. Hypotenuse, which is 5, over leg, which is Y, Y, and its Sohal is the red. Its segment of the hypotenuse that it's adjacent to is 4. So now I'm going to cross multiply. I get Y squared. Now, if you go ahead and multiply 5 times 4, now it's not a perfect square, so I still got to go back and factor it and break it down. So if I put it back as 4 times 5, 2 and 2, pair of 2's, so Y is equal to 2 square root 5, and this is my RH. And now I found all of the missing pieces. And you can have radicals for the sides. So that is it for the 9-3 notes. So your homework this weekend is 9-3. Again, there are 17 questions in it. Do not wait until super late Sunday night. You will be very sad. Again, remember, you can use your similar information that you learned in Chapter 8 to solve these as well.